Hey everyone, today I'm going to be designing a URL shortening system, or more specifically Bitly, but I think this should just be called URL shortening system because this is a classic system design question. And if you're a beginner and you've never done system design before, this is the best introduction into system design. You should definitely try this one out. Yeah, I think this is the first system design question I ever did because it's not too complicated. You're not worrying about too many things besides a client, an API server, a database, and then maybe one service depending on how you optimize it, one external service. But yeah, designing URL shortening system, let's just get straight into it. So, designing a URL shortening system similar to Bitly. And let's just go on bitly.com. So, how does Bitly work? You pretty much post in your long link like this, and then you'll get a short link. It requires me to log in, but essentially you take this long link like this up here, and then you'll get a short link, something like this. And then that's what is given to you, and then usually you'll give users the short link, and when they access the short link, it converts it back to a long link when it redirects them back to a long link. So that's kind of what the functional requirements are. They're just giving us the functional requirements straight up. But during a system design interview, you should be polling the interviewer and trying to figure out what the functional requirements are. You should be asking them questions. Okay, what is a long URL? Um, when we get the long URL, what does a short URL look like? How many characters is it supposed to be? Different things like that, and maybe they'll throw it back to you on how many characters it should be, like certain questions, and then you could debate it. But definitely trying to figure out the functional requirements. If for more senior candidates, you need to be driving this discussion and driving the requirements gathering. So what are the functional requirements? So the functional requirements are pretty much to submit a long URL and receive the shortened version, like I mentioned. And then on the other side, being able to submit that short URL and then being redirected back to the long URL. What else? And then also pretty much being able to, there's an extra part of being able to provide a custom alias or an expiration to your shortened URL. So pretend I have a URL and I want to expire it after 1 day. Users, after they're given the shortened URL, for the first day, everything will work fine. They hit the short URL, they get the long URL back, and they get redirected to the right site. But after the day passed, maybe if they try to access it a week later, they hit the short URL. They should get a 404, some sort of not found kind of thing. So that's the functional requirements. And then lastly, what is the scale? We need to know what the scale of the system is because the scale of the system is going to drive your non-functional requirements. So now we know that we need 1 billion shortened URLs and we need 100 million daily active users. That's quite a lot of scale. So we need to make sure we handle that accordingly. So this is the recommended delivery framework. I'm going to zoom in for a lot of these actually. So when you're doing a system design, first figure out requirements gathering or do the requirements gathering. Even for coding interviews, do requirements gathering and figure out exactly what the question is asking. Once you gather the requirements, figure out what are the core entities that are going to be used, and those core entities being used are going to be used in your API design. Once you build out the API and the core entities, you kind of know the low level details. Start figuring out the high level design and data flow. So start building out the components of, okay, this is my client, this is my server, this is my database, and figure out how data flows between those. I think 4 and 5, I do them at the same time. And once we have a high level design, we start diving deeper into the different areas. So I think for URL shortening, one of the things that we probably will have to dive deep into is how do we generate that shortened URL efficiently. So yeah, let's just hop into next steps. So they want us to generate the non-functional requirements for the system. So what are the functional requirements? We mentioned that before. So when we're listing out the non-functional requirements, let's take a step back and think about how our what are the intangible things, or functional requirements are kind of what exactly does our system need to do, and non-functional requirements are more of like what are the system characteristics? How is our system supposed to behave? Mostly in terms of mostly start listing out the scalability, reliability, availability, all those ilities essentially. So what I start thinking of the cap theorem right away when I'm trying to figure out the non-functional requirements. So for what with regards to the cap theorem, let me shorten this. Cap theorem, consistency, availability, or partition tolerance. I think I would for this one. There's no it's not like a banking system or ticket master. So consistency, I guess, is not that important. I think what's more important is availability. Our system should be able to redirect people 24/7. It should not be down. Because if it's down, I have a shortened URL that I want to turn into a long URL. It's not gonna it's just then if the system's down, then I won't be able to get served. So it's very important to have a high availability. So we'll prioritize availability over consistency. And if you're not familiar with the cap theorem, it pretty much means that you could only choose consistency over availability if there's a partition, if your data is partitioned, essentially. But yeah, or if your system is partitioned, essentially. So you could kind of only choose one of the two. So I'm going to choose availability for our system over consistency and dive into the cap theorem if you don't understand why this trade-off exists, because it's really important and it makes a lot of sense. Maybe I'll do a video on that actually if y'all want. Comment down below if y'all want that. So we prioritize availability over consistency. What else? We probably want consistency, or when it comes to the URLs, we don't want different long URLs having the same short URL. Don't want different URLs having the same short URL. So we want that to behave consistently or properly. So no collisions. Users can optimally provide a custom alias or expiration time. Yeah, we don't have to really think about that. So users should be able to access the original URL by using the shortened URL. So yeah, I think when it comes to that, we already have the high availability. They want to be able to do that whenever. But I think one thing is the redirect has to be really fast. So let's say sub under 200 milliseconds or under 150 milliseconds to redirect. So if I hit a short URL, it gives me I'm on the long URL in the blink of an eye, so I don't really even notice. So I think these are the more important things for what we have here. And yeah, I think let's just get some feedback on that. I think that's because everything when you think about a system, everything needs to be scalable, anything needs to be reliable, everything needs to be fault tolerant. But during this interview, you need to figure out what specifically is important for this question that's gonna make this question interesting and gonna have like some good conversations. So I think for this, like, how are we gonna generate unique short URLs? How are we gonna redirect really fast? Why we need to prioritize availability over consistency. All these are more important than just saying, oh, we're just gonna add load balancers. We're just gonna horizontally scale our app servers. You know what I mean? So let's just get the feedback. See if I'm missing anything. Do you get a mid response here? Nice. So you correctly identified all the important non-functional requirements of the system. Your answer was well contextualized, showing an understanding of why requirements matter for each system. Let's view the sample answer. ensure uniqueness, low latency, availability, scalable. Yeah, I guess. Yeah, it needs to be like it needs to be able to support. Cool. Let's get straight into the next part. What are the core entities? I think here, when we list out the core entities, let's just list it out. This this is a little bit, or we start listing out a little bit of our data model. So all I see right now is we're gonna have some sort of URL, and we're gonna have a URL ID, kind of a unique ID, and then we're gonna have a long URL, and then the short URL version, string, 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 and table stakes things like created at. Wait, there's gonna be UID. These are table, and I'll fill this out more. Updated at. These are more table stakes things for metrics. But we have a long URL, short URL, and we said we're gonna have an alias and alias, and also we're gonna have an alias. Oh, and also a expiration. Could be like a UTC or something, but let's just say literally that's our only entity here, because probably users as well if they want to log in. But let's just say we don't even need to care about that. Below the line is users, but we can write it out in case the AI gets mad. Below the line. So we have a URL. Essentially, from the client side, I just need to specify my long URL. We're gonna generate a short URL, return that back to user, and store that entry in the database. Now that we have that entry in the database, every time they have a short URL, we query the database, we turn it into a long URL and redirect them. That's the very high level. So let's just get feedback on this right now. Nice. So we identified the core entities needed to store the original and short URLs. Your understanding of the question was clear and accurate. Yeah, core entities, original, short, user. But I think we just need to store that in one table. So what are the main APIs of the system? Write your answer in the green box. So what I do essentially what I do to satisfy my API requirements is I look at my functional requirements. I'll take a screenshot right here, and I start to figure out what are the APIs I need so that I can hit all my functional requirements. So for example, users need to be able to submit a long URL and receive the shortened URL. So that's automatically endpoint. So if they want to create a URL entry, we'll say post. I don't know, maybe short URL. We get a short URL, and then we pass in inside the body. We'll say description generates a short URL. In the body, we'll do we'll store the long URL, and we probably need to it'll be the URL, but we'll need to encode it so it doesn't get messed up. Or we don't need to URL encode it because it's in the body. Alias, optional string. Expiration date. Maybe enum day, week, etc. Like some sort of enum. So that generates us a short URL, and and what do we return back? Pretty much this is just pretty much JSON, where these are going to be the keys and these are the values. Return back a short URL, which is a string. And they can display that to the user for them to copy and paste. But essentially, users submit a long URL and receive the shortened. They can pass in a, yeah, that makes sense. And then now, users should be able to access the original URL using the shortened URL. So, yeah, so that's a little post request there. Then we'll do a little get request. So get long URL. I forget what the best standard is for APIs. It's supposed to be camel case. Let me look that up real quick. For REST. The best practice to have a hyphen, not camel's case. Okay. That's good to know. So now we get long URL, generates, gets a short, converts a long URL to short URL, or converts a short URL to long URL and probably redirects user. Maybe we'll send them like a 302 or a 301. 302 is a redirect temporary. And here for query parameters or path parameters, we'll just do short URL right here, and then the body or the path param, and it'll probably be the hash, like the short URL. We don't need to include the whole prefix or the domain name. Short URL, more specifically the hash. Without the domain name. It's going to be like hellointerview.com/a hash. We don't need to include hellointerview.com. So I think that hits all. We can post like there, and then we should be able to get. I think that hits all of our functional requirements. So let's just get feedback on that. Nice. You correctly identified the two main API endpoints required for the system. Your API design includes all the necessary input parameters and output responses. You provide clear descriptions for each endpoint explaining their purpose and functionality. Consider renaming the post endpoint to URLs instead of short URL to better align with run. Okay, that makes sense. You could simplify the get endpoint to just short code rather than long URL for cleaner. That makes sense. So think about using HTTP code 301 instead of 302 if the short URLs are not expected to change frequently. That makes sense. Cool. What did they use? What? They used the 302? Okay. I guess we hit kind of the same thing, but the naming convention was different. And cool. Let's just go to the next question. High level design, my favorite part. You'll just start with a first functional requirement and build. Okay. Cool. So the first high level design question is, how will users shorten a URL? Don't worry about the algorithm for generating the new short. We'll get to that later. So how will user just high level design shortening a URL? So let's have our clients. Let me zoom in. So we have our client here. Let's just have a very simple, like we could have an API gateway, a load balancer, etc. if we want to horizontally scale it, and we probably would want to horizontally scale it. So let's just throw the load balancer in there for now. Need to zoom in. So we have our load balancer. Clients communicate directly with the load balancer. And then we're going to have different app servers scaled horizontally. When they hit the app servers, we're going to have our database where we're going to store the URL entities, and the app server is going to run our API endpoints. So the app server is kind of hit the DB. Then what we're gonna do is we're gonna copy and paste our URL, because that's essentially, we're gonna have the database is gonna store the URL here. So how users shorten a URL? So essentially, the client is gonna hit the load balancer. The app server, the load balancer is gonna find an app server that doesn't have that much load, or round robin. The app server is going to, and we're abstracting this away on purpose, but it's going to generate the short URL. It will generate the short URL. Then you'll enter that into the database, the long URL with the short URL, create an entry into our URLs table. And after that, once it's in the URLs table, it's going to return a response, which is going to be the short URL that it generated. I mean, let me just describe it to this person, but let me just think about that. I think that's good. So pretty much how we're doing this is we have our client, which is going to be a web browser or a mobile device or whatever the client is going to be using, and they're going to be wanting to shorten a URL. So they're going to pass in a long URL. So we have a load balancer there because to handle our non-functional requirements, we're going to horizontally scale our app servers. But essentially, when they're going to hit the load balancer, they're going to hit an app server based on either round robin or based on usage. But when they hit the app server is going to generate them a short URL, and that's abstracted for now on how it's going to generate it. We'll cover that in maybe other areas of the deep dive. But once it calculates the short URL, it's going to create a row in our database for our short URL that contains our long URL and our short URL. And yeah, we're going to enter that row into the database. And once that's in a database, we just return back to the user the short URL that we generated. So now it's in our system, and that's kind of how they store in the URL, because now it's in the database. Whenever they pass in that short URL, and we could find it in the database and convert it to a long URL. That's kind of what I'm thinking. That's kind of the data flow. Let's get some feedback. I mean, what went on? Nice. I think we're going really good on this. What I didn't do. So what I did right. I provided a clear and comprehensive high-level design and effectively addressed the URL shortening requirement. My design included key components such as a client, a load balancer, app servers, and a database, and demonstrating scalability considerations. I explained the data flow well, from client's request to storing the URL mapping in database and returning a shortened URL. Well, let's see what the expected result was. Yep. Post, generate, then we save it. There's a little typo there. So how will users be redirected from a short URL to the original long URL? Yeah, I think I mentioned that before. Let's see. So users will be redirected from a short URL to the original long URL by first sending in their short URL to making the GET request. That GET request gets routed to one of the app servers. The app server will then extract or pretty much query the database based on the short URL. It queries the database, and it will figure out the long URL associated to that specific short URL. And once it does that, it will send back a 302 or 301, probably 302, because we just want them to hit the server every single time so we can calculate analytics and stuff like that, probably, instead of 301, which is for permanently moved because it might never hit the server. Because, yeah, we want to handle expiration and stuff like that as well. But yeah, essentially, that's kind of how they'll be redirected. Um, yeah, we'll just need to query the database to get the long URL, and then redirect the client based on the long URL that we extracted. Get that feedback. 703. Nice. Just saying random stuff now. All right, let's move on. Deep dives. Let's get into the deep dive. See, this question is a lot faster than Ticketmaster. We already got to deep dives real fast. So focus on quality over quantity. It's not necessary to answer every question. Depending on your level, you'll do anywhere from 1 to 3. How can we ensure that each shortened URL is short and unique? Update the whiteboard if necessary, then explain your answer. How can we ensure that each shortened URL is unique? Let's see. I mean, there's multiple ways to do that. I think one of the main ways that I'm thinking right now is like there's multiple ways. One way is just to have an auto incrementing integer or something like that, and auto incrementing the URL. But then usually with these long URLs, you want them to be a predictable pattern. So you want them to be a very specific number or very specific amount of alphanumeric characters. Say you want exactly 6 or you want exactly 10. I think it's just more aesthetic and just it's better than seeing hello interview 1, hello interview 2. And you could start actually trying to predict people's short URLs if you know that, which could get kind of weird. So I think just a randomly generated short URL of, let's just say, about 6 or 7 might work the best. So one thing we could do is, if we want it to be predictable, we can make it so, let me write down my thoughts of the different approaches. And then this one's going to require a little bit of thinking. One, auto incrementing. We can have an auto incrementing integer. But then now we need to kind of coordinate that across all the app servers, so it could be like less optimal. Maybe hash. We can hash the long URL. We can hash the long URL. Take the first 6, first X, characters. X will be determined based on number of URLs needed. For example, if we take 10, if we have 62 characters, or yeah, like 0 to 9, A to B, lowercase and uppercase, that's about 62 characters. And if we take 6 of those, we have this many options, which is a big number. But if we take 10, it's like even massiver number. So we just need to figure out how many URLs we expect. Let's say 6 for now, because we don't want to overkill it, because then it'll be too long. So I think 6 is good. So hash and take the first X characters. What else? That'll doing a long URL will and taking it and using a hash could be the best, because it allows us to, because given somebody else will give us the same long URL, we already figure out that it's shortened fast enough. So I think we could hash the long URL, or literally just randomly generate the long URL i.e. picking random car from 9 A to Z. Yeah. And then essentially what we can do is we can have a service that generates these long URLs. Let's just do it like this. We can have probably some sort of queue that has available URLs. Let's just say queue with available URLs. And essentially what's going to happen is we're going to have producers producing URLs and adding them to the queue, but it's also going to do the uniqueness check. So essentially well, that's one way. If we go the third, and then they kind of pick from the URLs in order to pick yeah, there's multiple ways. Let's go with the third way, and we have a queue with available URLs, and we have workers generate, because even the hash function works as well, but when we hash it, in the app server, we just need to keep, what if there's a collision, then we could like add another random ID, but if we pre-generate the URLs, I think it'll be a lot faster. So workers generate URLs and ensure DB consistency or DB uniqueness before adding to the queue. Or essentially or not even a queue, sorry. We could just use like a Redis cache, in-memory cache. And then we have workers like a separate service inserting into this Redis cache. So we have separate URL gen service, adding into this Redis cache, but also ensuring that these are unique, right, based on the database. And then pretty much these app servers will use the Redis cache in order to figure out a short URL, and that's how it's going to use it. And that ensures uniqueness as well. And it's going to be pretty fast because all the like the Redis cache is going to be pre-generated, and then we could just pre-generate a ton, and during load times we'll be generating a ton and just have a ton in the Redis database as well. Yeah, kind of like that. That might be able to work. And worst case fallback, they just generate URL and check there for fault tolerance. So what I'm thinking is there's multiple approaches for generating URL. I think we could have an auto incrementing integer, but that will probably be less optimal because we want to probably to be consistent on how many characters our string has or our short URL has. So we'd probably choose something like 6 because it's more just I think 60 if we choose alphanumerical characters, that's 62 to the 6. So that's a ton of options. So we could either do auto incrementing integers, hashing the long URL, and taking the first X characters, or randomly generating long URLs, or sorry, randomly generating the short URLs by just picking random characters from 0 to 9 for all 6 characters. That will give us a very unique URL for every single character or for every single long URL. And yeah, essentially, but then this assumes that they could probably shorten the same URL twice. If we don't want them to shorten the same URL twice, we can go option 2 of hashing the long URL so we can figure out collisions right away. But how we ensure uniqueness is all of the different app servers will actually just reach into some key value store or some Redis cache, or maybe some, or probably maybe some queue that they consume from. So let's just say Redis cache. We populate some Redis cache with URLs that are available, and we have another service that's populating this Redis cache asynchronously, and app servers just pull from this Redis cache so that they don't have to generate themselves, and they already know that this URL is going to be unique because our URL generation service already ensured that it's unique in the DB. So that way our app servers can operate really fast because they're not doing any logic. They're just reading from Redis and then inserting to the database. That's kind of what I'm thinking. Get some feedback. Nice. Oh, no. So using global counter with a basic C2 encoding. This method guarantees uniqueness without the need. Show URLs. I didn't want to do that. What's this? The system. Yeah, they use Redis for a global counter. I mean, there's multiple approaches to it. I already mentioned that as the other one, auto incrementing global integer. Specify how the hash function you would use for generating as different functions. Yeah, probably like SHA, MD, all that stuff. Clarify the exact number of characters you'd use for the hash. I said 6. I already said that though. Elaborate on how you would handle collisions. I think I mentioned that. So this one, it would just have to keep generating long URLs and appending some sort of like maybe timestamp in order to get a new hash if it collides. But yeah, whatever. We move. How can we ensure that the redirects are fast? First off, we could use like a NoSQL database because our database here is, we could say this is NoSQL. for availability and speed. And most NoSQL actually prioritize availability too. And our data is not relational. Okay. What else? We probably need. We'll probably have. We'll have our Redis cache for that stores long URL to short URL combinations, and we'll specify the expiration date there as well. So how can we ensure redirects are fast? So first off, we'll use a NoSQL database that's optimized for availability and speed, something like DynamoDB. Our data is not really relational, so NoSQL here will keep things simple because we're really only storing one table, and after that, that will help speed up our queries to the database. Yeah, and then what we can do is, since database queries are always usually slow because they're mostly reading from disk, we can introduce some sort of in-memory data structure using Redis or something, or in-memory cache. And that in-memory cache, we can use Redis, and essentially what it's going to map to is it's going to map long URLs to short URLs. So first, app servers, they're going to check if in the Redis cache we have an unexpired entry of that long URL, and if we don't have an unexpired entry, we just get the short URL right away from there and return it back to the user. And since it's in memory, it's going to be a lot faster. Yeah, that will handle pretty much doing that fast. We just need to make sure the Redis cache doesn't get too big, and purge stuff, like evict stuff if it gets too big. So we could do like a least recently used Redis cache or something like that. So yeah, that's kind of what I'm thinking. Let's go. So using Redis is good. Using NoSQL is good for this use case. The trade-offs, such as managing cache size and potential expiration. Consider elaborating on the eviction policy. Okay, it would be beneficial to discuss the process of updating the cache when new mappings are created. Yeah, you're right. Pretty much, the cache is updated when we have a cache miss. So essentially, if I have to go to the database in order to figure out the short URL, I want to store that into my cache. So the next time somebody has to get the long URL or short URL from a long URL, they don't have to go to the database. How can your system scale to support 10K redirects, reads per second? I think just a combination of, yeah, so 10K redirects definitely have a ton of different app servers, or being able to horizontally scale our app servers will help when the load is high. Using our Redis cache as well to avoid having to read from the database and putting too much load on the database. That's also going to help as well, having our Redis cache there. And then, yeah, we can also, well, since we're using NoSQL database, something like DynamoDB is already horizontally scaled. So yeah, we're pretty much horizontally scaling both our web layer, web service layer, which is app service layer, and horizontally scaling our data, our data layer, which is our database. And yeah, I think also, yeah, pretty much these are just reads. So that's essentially what's going to be that's how we're going to scale that. Finish off strong. Do 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 do. Cool. Pretty much did pretty good except for that one question. That's how you design a URL shortening system. This is very, very beginner friendly, and if you're trying to learn system design, try this one out. Um, yeah, see y'all in the next video.